Hello friends, welcome to Learner's Planet. Friends, this is our first session for Coordinate Geometry Advanced Problem Solving. We have discussed all the basics. In fact, I have explained everything in detail in our basic sessions. So you must attend the basic sessions before you come for this session, because I will be taking directly problems in this session. I will not be discussing the basics once again. So unless until you are comfortable with the basics, do not come to this session. Do attend the basic sessions before you come over here. Okay, so let's take the first session of the problem. Let's start with the basic problem. If the origin is one end of the diameter of a circle whose center is this, then the other end of the diameter is. Now see, for a circle, this is diameter, center is nothing but the midpoint of the diameter, right? If origin is the one end, so one end is origin, circle center is -1 and 2, then the other end of the diameter. So we have to find out the coordinates of this point, right? This is one point, this is other point, this is diameter, this is center. Now as I told you, center is the midpoint of the diameter. That means x plus 0 by 2 is equal to -1, right? X by 2 is equal to -1. That means x is equal to -2, right? Similarly, 0 plus y by 2 is equal to 2. That means y by 2 is equal to 2. That means y is equal to 4, right? So -2 and 4. These are the coordinates of other end of the diameter. So very simple concept we have used over here. The center of the circle is also the midpoint of the diameter. Okay? The distance of the point xy from the origin. So that's pretty simple. You must be knowing the distance formula, that is x2 minus x1 whole square plus y2 minus 1 whole square root. And from origin, if we wish to find out the distance of xy, that means this is actually x, this distance is x, and this is y. So we have to find out this, so that will be nothing but root of x square plus y square. That is simple Pythagoras theorem I am using. Okay, so you can use distance formula, you can use Pythagoras theorem as well. The distance of the point xy from y-axis. Now this is point xy and this is y-axis, right? So distance of xy from y-axis is what? It is x, so it will also be x. Okay, and distance will always be positive, so you can take it as modulus of x, because absolute value of distance will be a positive value. The middle points of sides of a triangle are this is centroid of the triangle is. Friends, centroid is actually concurrence point of medians. And what is a median? Median is, suppose this is a triangle, then from this point, if we drop a line that bisects this line, or that connects with the midpoint of this line, then this is the median, right? Similarly, this is the median, this is the median, so this is the centroid, that is concurrence point of medians. Now here in this case, the three coordinates of this lines are given, that is midpoint of the sides. And we have to find out the coordinate of the centroid, right? There are two ways of solving this problem. As of now, I'm discussing the regular method, the manual method. So I assume this point is x1, y1. This is x2, y2. This is x3, y3. Now from here, x1 plus x2 by 2 is equal to -4. That means x1 plus x2 is equal to -8. x2 plus x3 is equal to 12. And x1 plus x3 is equal to 14. Similarly, y1 plus y2 is equal to 4. Then y2 plus y3 is equal to -4. Then y3 plus y1 is equal to 18. Now if you take these two, x2 plus x3 is 12 and x1 plus x2 is minus 8. If I deduct this from this, I'll be getting x2 minus x3 will be cancelled. So x3 minus x1 is equal to 12 minus minus 8, that is 20. Now if I add these two, x1 will be cancelled. 2 times x3 will be 34, so x3 is 17. Okay, so x3 is 17. If x3 is 17, x1 will be minus 3 and x1 is minus 3 and x2 is equal to minus 8 plus 3. So x2 is equal to minus 5, right? And generally you don't have to find out all the coordinates, you just find out any one of the coordinate, right? Suppose I have found x1, then I should find out x1 y1 combination, right? So y1 y2 plus y3, y1 plus y3. So if I deduct this equation from this, so y3 will be cancelled and y1 minus y2 is equal to 22, right? And y1 plus y2 is equal to 4. So I add both of them. So 22 plus 4, 26. So 2y1 is 26. That means y1 is equal to 13. So I got this coordinate, that is x1 y1. So x1 y1 is minus 3 and 13. Now the important thing that you must be knowing, that is the centroid divides the line in 2:1 ratio starting from vertex. So if this is centroid, it will divide this line in ratio 2:1. That means we have points minus 3, 13 and 6 and minus 2, and we have a point that divides, I suppose this point is xy, this is the coordinates of this are the coordinates of centroid, and they divide this line in the ratio 2:1. That means this length is double of this length. Okay. Now since x coordinate in all the three options are unique, you just find out the x coordinate, right? No need to calculate the entire thing. So just find out the x coordinates, and we have discussed the section formula. So x is equal to 2 into 6 m1 x2 plus m2 x1 upon m1 plus m2. So 2 plus 1, 3. So 6 2s are 12. 12 minus 3, 9 by 3 is equal to 3. So x coordinate is 3. So that is there only in this option. So this is the correct option. No need to go for the y coordinate, because the fourth option is cannot be found. So actually it can be found. So no need to go further. Apart from that, see, if you know, thus the x coordinates are unique in all the three options, so no need to calculate y coordinates at all, and just calculate one x coordinate. No need to calculate all other x coordinate. If you get one this point and one this point, then your problem is done. Then you can easily find out the answer, right? So this is one approach, and the other approach is, just listen to me carefully. Now see what I do, I just draw a rough sketch of this triangle, right? Just a rough sketch of this triangle. Minus 4, 2, that is somewhere it will be 1, 2, 3, 4, somewhere minus 4, and this 2 over here. So this is minus 4, 2, right? Then next is 6 and minus 2, that is y coordinate negative, somewhere 6 is over here, then minus 2. And the third one is 7 and 9. So one step this side, because this is 6, so this must be 7, and 9 somewhere here. Okay, now you get a triangle. Now what is centroid? Centroid is the concurrence point of medians. I draw one median. I just change the color. I draw one median. I draw a second median, and I draw third median. Though you do two median, then also it is enough. Now you can very well observe that the centroid is lying in the first quadrant, right? So 6 and minus 2, it is already eliminated because that is a point, it cannot be centroid. 9 9, it cannot be centroid because 9 is moving outside the middle line, right? So it cannot be the correct option. So we just are left with one correct option. 3 3, because cannot be found, cannot be the correct option, because we can find, definitely we can find. If we go with the proper method, we can definitely find, right? So it cannot be the correct answer. So we are left with just 3 and 3. So without any much work, without any lengthy calculation, you can answer the question. But yes, you should be clear with both the methods, as I've told you earlier also, because every time the options may not be supportive, right? So in this case, the options are supportive. So I chose this method to solve this problem, and the other method also I discussed. But in that case also, just calculate x coordinate only, and that too just for 1 point, right? You no need to calculate for the coordinates of all the 3 points, right? All the 3 vertices precisely. Okay, so just try to understand the situation, and if you can go this way, then the problem will take hardly 30 seconds for you to solve, right? Now in this case, the vertices of triangle is this, this and this, the length of the median through A. So the length of the median through A, so one point is A, other point is the midpoint of B and C, obviously. So midpoint of B and C will be what? 5 and 1, 6 by 2, that is 3. 1 minus 1, 0 by 2 is 0, right? So this is one point and this is other point, that is whatever you can say, M, right? So you have to find out this length. So using distance formula, you can easily do it. 3 minus 1, that is 4 square, that is 16, plus 9, that is 25. So square root of that will be 5. So very simply you can do it, right? No need to draw any diagram. The points this are collinear vertices of a rectangle, parallelogram, square. Now you must be knowing the basic properties of rectangles, parallelogram and square, right? In case of a square, all the 4 sides are same. In case of rectangle, opposite sides are equal in length. In case of parallelogram also, the opposite sides are equal in length. But in the case of parallelogram, diagonals are of different length. But in case of rectangle, the diagonals are of same length. Okay, so all these properties will be using to solve this formula. First of all, what I do is I just mark the points on coordinate plane. Now 0 0, obviously, AB somewhere in the first quadrant, minus A minus B, just reflection of that, because A is getting negative, B is getting negative, so it will be somewhere here, right? It is here. Now one interesting point you can note down over here. See, A and minus A, the midpoint will be 0, and B and minus B by 2, midpoint is 0. That means this line is passing through origin. And we have 1.00 also. Now we can easily see that these 3 points are collinear. So whatever is the location of the 4th point, maybe in this, maybe on this line, maybe somewhere else, but it cannot form a quadrilateral. It cannot form a 4-sided polygon. It cannot, right? And we have the 3 options with 4-sided polygon. Maybe it is a rectangle, maybe square, maybe parallelogram. But if the 3 points are collinear, maybe the 4th point is here or here. You at max you can get a triangle, you cannot get a quadrilateral, right? So no need to check further, the points are collinear. Okay, since the 3 points are collinear, the 4th one has to be collinear because the other options are not satisfying. Okay, so no need to go for any lengthy calculation, no need to find out the length of sides and diagonals and all that. Okay, the point on the axis of y which is equidistant from these 2 points. Now point has to be on axis of y, that means x coordinate will be 0. So this option is discarded, right? In this case, y coordinate is 0. Okay, now the point on, suppose it is a 0y. Now distance of the point 0y from -1, 2 and 3, 4 is same. Okay, so we can simply use a distance formula to find out the solution to this problem. Apart from that, what you can do is you can go by options, because we just have two options over here. We need to check. So 0y, suppose it is 0, 4. Then the distance length of this line will be what? 1 plus 4 and 4 minus 2, 2 square, that is 4. So it is root 5. And in this case it is 9. So it cannot be the correct answer. Suppose it is 5. So 5 plus 1, 6. I'm sorry, it is 0 and 5. So 1 plus 5 minus 2, 3, that is 9. So that is root 10. Here it is 9 plus 1, 5 minus 4 whole square. So that's also root 10. So 0, 5 is the correct answer. So instead of making equation, you just go backward. Now the points, this are the vertices of right angle, equilateral, acute angle triangle. Now once again we can choose the comfortable values for variable. I suppose maybe a, b, c as maybe 1, 2, 3, 1 minus 1, 2, whatever you can assume. So the 3 points are a, b plus c, so that is 1, and b plus c, that is 1. b, c plus a, that is minus 1 and 3, and the third one is c, a plus b, 2 and 0. Now first of all, let's find out whether they are the three vertices of triangle or not. So if they are three vertices of triangle, if the slope between these two and these two will not be equal. So I just quickly find out the slope between these two. So 3 minus 1, 2, and that is minus 1, minus 1, minus 2. Here the slope is 3 by minus 1, minus 2, minus 3. So in both the cases the slope is minus 1. So if the slope is same, that means the 3 points are collinear. That means they cannot form a triangle. Right? If the 3 points are collinear, they cannot form a triangle. Right? So they are not vertices of any of these triangles. In fact, the 3 points are collinear. Okay, and I have chosen the values of A, B, C at very random, so you don't have to worry, no need to go for the cross verification, right? So whenever you have to find out the area of the triangle, just first make sure that they form a triangle, right? That means the 3 points should not be collinear. And how do we check the slope? How do we find the slope between these 2 points? That is y2 minus y1 upon x2 minus x1. So 3 minus 1 in the denominator, minus 1 minus 1. Okay, so that we have already discussed in the basic session. So I hope you are clear with this. The vertices of triangles are this, this and this. The orthocenter of the triangle is at. See, orthocenter is nothing but the concurrence point of altitude. Here first one point is this, 8, 0 somewhere here and 0, 14 somewhere here, right? So this is the triangle. Now orthocenter is concurrence point of altitudes. Now we can very well see two altitudes are meeting over here at the origin, right? Obviously the third altitude will also meet at the same point. Okay, so altitude, concurrence point of altitude is nothing but origin. So no need to go for lengthy calculation, no need to apply formula. Since the question, these sort of questions are asked in competitive exam, so they do not expect from you to apply lengthy formula, or they do not expect lengthy calculation, right? So once you are logically clear, then there is in these sort of problems you will hardly take 30 to 40 seconds, right? And very easily you can see that this is one altitude, this is other altitude, so the third altitude has to come over here only. It cannot go anywhere else. So if you don't know that this altitude will come over here or not, no need to worry. In that case, even two altitudes are meeting, then also it will be an orthocenter. Okay, so I hope you are clear. The vertices of triangle are this, this and this. The orthocenter of the triangle is, for once again we'll draw a rough figure. Just mark the points. 0, 3, 0, 3 somewhere here, minus 3, 0 somewhere here, and then 3 0 somewhere here, right? Now once again, orthocenter is what? That is concurrence point of altitudes. Now if we just check the slope of this line and this line, if these two lines are perpendicular to each other, then it will be a right angle triangle and this will be the orthocenter, right? So the slope of this is 3 and this is 3, that's 1, and this is 3 by 3, that's 1. I'm sorry, minus 1, right? So product of the slope is minus 1. That means that this line and this line is perpendicular to each other. That means this is 90-degree angle, and if this angle is 90-degree, that means it is a right angle triangle. That means this will be the orthocenter. So the orthocenter will be nothing but 0, 3. Okay, I just write it once again over here. How do we find out the slope? y2 minus y1. So this is 3 minus 0 upon 0 plus 3, so that is 1, and this is 0 minus 3 upon 3 minus 0, so that's minus 1. So if the product of the slope is minus 1, then the lines are perpendicular to each other, right? So this line is perpendicular to this line, right? Slope of this line 1, slope of this line minus 1. So the lines are perpendicular to each other. That means this angle is 90-degree. If this is 90-degree, then this particular point will be concurrence point of altitudes. One altitude is this and the next is this. So the third one will also meet at the same place, right? Area of the triangle whose sides are along these lines. So I just draw a rough diagram. Now x is equal to 0, that means this line, y is equal to 0, this line, 4x plus 5y is equal to 20, right? So when you have to find out the length of intercept, what you do, put x is equal to 0, then get the value of y. So when x is 0, y is equal to 4. So this is one point from which this line is passing, so that is 0, 4, and this point, put y is equal to 0 and get the value of x, so that is 5. So that is 5, 0. So this is the third line. So this is y is equal to 0, that is x is equal to 0, and this is the third line. So we have to find out the area of this triangle. Now that's very simple. That's a right angle triangle. This length is 5, this length is 4. So half of 4 into 5, that is 10. Okay, pretty simple. Okay, area of the triangle formed by these three lines. So these are the lines, suppose like this, whatever. Okay, so 3 points. First of all, we need to know these are nothing but the intersection points of the lines, right? Intersection of these two and these two. Okay, so from these set of points we can calculate the area of the triangle, right? And for that we use the determinant method, that is half I can say x1 y1 1, x2 y2 1, and x3 y3 1. Now if the area of the triangle, whatever you calculate, if it is 0, then the 3 points are collinear, right? So this formula you must be knowing. When you have 3 points, you can easily calculate the area of the triangle. There are various other methods of calculating area, but in this case it seems to be simple, so just do it quickly. Y is equal to x and y is equal to 2x. The intersection point will be 0, 0 obviously. So one point is 0, 0. Then y is equal to x and y is equal to 3x plus 4. We take these two. So put up y is equal to x. So 3x plus 4 is equal to x. That means 2x is equal to minus 4. That means x is equal to minus 2. And y is also minus 2 because x is equal to y. So one point is this. Then y is equal to 2x. So I put up 2x over here. So 3x plus 4 is equal to 2x. That means x plus 4 is equal to 0. That means x is equal to minus 4. So if x is minus 4, y will be minus 8. Okay. Now these 3 points we got. Put up the values over here in the determinant. x1 y1 1, that is 0 0 1, then -2 -2 1, -4 -8 1, right? And how to solve a determinant? You must be knowing the formula for that, but here we'll take, because these two columns, these two elements are zeros, we just have to do the calculation along this. So that is 1 into this into this minus this into this. So -2 into -8 16, minus -4 into -2, that is 8. So 16 minus 8 8, and half of that, that is 4. So area of this triangle is 4 units. Okay, and I just go for a quick recap how to solve the determinant over here. Use this one. So that is half, just keep it aside, x1, then y2 minus y3, then plus, minus y1, x1, x2 minus x3, then plus 1, x2 y3 minus x3 y2, right? And out of the bracket we have half. So this is how we can calculate the value of this determinant. Okay, so in this case it is very simple, because these two elements are 0, so this calculation will be 0 and this calculation will be 0. So no need to directly write the third step, that is corresponding to this step, 1 this into this minus this into this, and no need to write the formula directly. You should be able to apply the determinant formula, right? You should directly apply, no need to write the formula. Area of the triangle is 5 units. If two vertices are this and this, the third vertex is on the line y is equal to x plus 3. The coordinates of the vertex are. So now the problem is really very simple. The third vertex is on this line, that is y is equal to x plus 3. That means the coordinate of that vertex should satisfy this equation, right? So here y minus x is equal to 3. So we just have to check the difference between y and x coordinate where it is 3. So this is cancelled, 3 by 3, this is cancelled, this is absurd. 13 minus 7, that is 6 by 2, it is 3. So this is the correct answer. So no need to go for any sort of paperwork, right? Whenever you have to see whether the given points satisfy the given point are on the line or not, just put up the points in the equation of line, and if they are satisfied, then definitely these points are on the line. Okay. Okay, 2, 1, minus 1, minus 2, D, E, F are midpoints of side BC, CA and AB respectively of a triangle ABC. The vertices A, B, C are, I draw a triangle, that's A, B, C, then this is D, this is E, and this is F. Then D is 2, 1, this is minus 1, minus 2, and this is 3, 3. Okay, so see, F is the midpoint of A and B. That means x coordinates of A and B divide by sum of them divide by 2, that should be 3. So we just check through options. So 0 plus 6 divided by 2, that is 3. 0 plus 6 divided by 2, that is 3. So that is correct. We don't have any other 0066 combination, no problem. Then also we just verify 6 6 and minus 2 4, that is, this is B and this is C. So B and C midpoint is 2 1. So 6 minus 2 4 by 2, 2 correct. 6 minus 4 2 by 2, 1 correct. So this option is correct. Okay, no need to make any sort of equations. Now this problem, orthocenter of triangle whose vertices are given as this. So I just draw a rough figure. It's 0 0, then 3 4 somewhere here, and 4 0 must be here. That's 3 4. So this is the triangle. Okay, this point is 3 4 and this is 0 0. Okay, now this line 4, the slope is 4 by 3, and this line the slope is minus 4 by minus 1, that is minus 4. That means this line is not perpendicular to this line, right? So orthocenter will be none of these 3 points, right? So orthocenter will lie somewhere here in this, inside this triangle. Now see this line, this is a y is equal to 0 line, or y is equal to constant line, right? This entire line is y is equal to constant. Over here it is 0, but it is y is equal to constant line, right? And altitude will be definitely perpendicular to this, that will pass through this point. Okay, so if this line is y is equal to constant, then on this line x will be equal to constant, right? So here we can see the x coordinate is 3. That means over here, that is, suppose this is the concurrence point of altitudes or orthocenter, we can say. So the x coordinate should be definitely 3. We don't know about y coordinate. Definitely it should be some less than 4, but x coordinate will definitely be 3. So we just have one option with x coordinate is 3. Okay, so this way you can do this problem simply. Otherwise the manual method is really difficult or lengthy, or you can say time consuming, right? So just look at the option, just draw a rough diagram, look at the option. If you can solve this problem in 30 seconds, then it's okay. Otherwise just leave this sort of problems, okay, that they will be very lengthy. Once again, orthocenter is the concurrence point of altitude. So this is one altitude, this will be the another altitude, and the third one. So precisely this is orthocenter. And what logic I am applying over here, this line is y is equal to constant, so this line must be x is equal to constant, because this line is perpendicular to this line. Okay, that means in this entire line x should be constant, right? And orthocenter will lie on this line only. So if x is equal to constant, whatever is the value of x over here, that should be same on this line. Okay, I hope you are clear.